This is Viterbi Voices, your chance to hear stories about research, classes, student life, and more.
Directly from our students, faculty, and other members of our engineering community. All right here at the USC Viterbi School of Engineering.
Welcome back to Viterbi Voices. We're back with another bonus episode. My name is Paul Ledesma, Director of Undergraduate Admission here at the USC Viterbi School of Engineering.
And my name is Audrey Roberts. I'm a senior studying mechanical engineering here at USC.
Well, here we go. Our penultimate bonus episode series, our penultimate episode of I don't know. It's the second to last one of our series of faculty roundtable discussions, this time highlighting the faculty from the Ming Hsieh Department of Electrical and Computer Engineering. On this conversation, I moderated a discussion with Dr. Antonio Ortega, Dr. Keith Chugg, and Professor Mark Redekop, a fan favorite at the USC Viterbi School of Engineering. Many people know Professor Redekop as a favorite, but also, I mean, all three of these faculty are very well renowned and do some really cool stuff. And this conversation not only is cool, it has a lot of fun parts to it. There's a cameo of one of our VSAs mentioned by faculty in this. I won't spoil it, but be on the lookout. The faculty call out one of our students as being very cool, and I'm gonna just tease you with that. There is not only just cool stuff and fun stuff that we talk about, but this is a really cool, in-depth talk about the discipline of electrical and computer engineering, especially for students that are trying to understand where they lie on the spectrum of computer science and computer engineering, software, hardware, and what is electrical engineering, because it's so hard to define. And I love the conversation that we had because it was described as the liberal arts program of the engineering school, meaning there's so much to it and it's very, very broad. And there is not a device or technology or service or solution that doesn't likely involve electrical engineers in some regard, right? With rockets, you've got different systems involved in that. Avionics, thank you. I was blanking on the word avionics. I was going to call it something else. But you got avionics systems inside of cars these days, the electronic system, everything has power sources. So sit tight. It's a really cool conversation. Dr. Ortega, Dr. Chugg, and Professor Redekop, I'm going to hand it off to them. Welcome to the USC Viterbi School of Engineering Faculty Roundtable discussion. Today, we will be joined with faculty from the Electrical and Computer Engineering Department, the Ming Hsieh Department of Electrical and Computer Engineering at the USC Viterbi School of Engineering. My name is Paul Ledesma. I'm the Director of Undergraduate Admission. I'll be your host and moderator for today's discussion, but I am the least important here. We're going to get to our faculty that will introduce themselves momentarily, but before we do so, I want to make sure we go over some ground rules for today's discussion. We're going to go for about an hour, and we're going to cover everything we possibly can about electrical and computer engineering and the undergraduate curriculum at USC. But in today's session, I'm going to moderate most of the conversation in the beginning, and then we'll get to questions and answers toward the end. But for the time being, please hold your question. You'll notice there is a Q&A feature in the webinar. Please don't use it. Please stay away from that button until I open up the Q&A feature. And at that time, I'll open up Q&A and we'll get to as many questions as possible. Don't make me deduct points from your application before you apply. So please don't do that. Without further ado, we're going to get into our faculty introductions here. So just because this is the order in which you're on my screen, we'll go with first Dr. Ortega, then Dr. Redekop, and Dr. Chugg.
Hi, everybody. My name is Antonio Ortega. I've been at USC for a number of years. Let's not say how many. And I really like it here. And one of the reasons I'm here is that every fall semester I teach undergraduate students, in fact, incoming freshmen. And that's, it's a great experience for me. Let me tell you a bit about my area. Well, the class I'm teaching undergrads is linear algebra. So math with lots of applications. And what I do actually is all coming from linear algebra. So it's fun to teach the intro class that you need the most to do what I do in my research and my graduate teaching. My research area is signal processing, images, video, audio, and also more generally, data sciences, machine learning, analyzing data, understanding it, using math tools to make sense of it. Yeah, happy to be here, and I can answer questions as we get into more discussion.
Thank you very much. Professor Redekop.
Yeah, thanks. So my name is Mark Redekop. I've taught for 16 or 17 years in mainly the undergraduate level. So I'm a professor of practice, which mainly focuses on teaching. I have worked and still maintain some work in industry, in the aerospace industry, developing hardware, processor chips, and also some custom software. And I like to bring that those concepts into my teaching. And so my area is computer engineering. So looking at essentially how hardware and software kind of come together to form a system to do a particular task. I teach several undergraduate classes, and if you did apply, I'd probably catch you in your freshman year in the second semester after you've had Antonio.
Awesome. And Dr. Chuck.
Hi, everyone. My name is Keith Chugg. I am also a professor in ECE, and I have been here a number of years, equal to N-2, I think, where Antonio has been here 10 years. That's somewhere on the order of 20-something years, since the mid-90s. My area of traditional expertise is digital communications, wireless communication theory. But I have a pretty broad background and interest. So also covering some signal processing, machine learning, and digital circuit implementation of application-specific circuits for these types of algorithms. Like Mark mentioned, I also interact quite a bit with industry, been involved with starting a couple companies, software company, wireless communications company. So I try to bring, some of the practical aspects of engineering practice into my teaching and combine that with our core analytical classes, because I typically am teaching core analytical classes. I'm also been the associate chair in our department for 5 or 6 years. I'm almost ready to rotate off. And so in that capacity, I've been pretty involved with iterating and evolving our course curriculum. And Mark and Antonio have also been involved in that in quite a bit of detail. Yeah, what else? Typically I teach junior level classes, one in probability and statistics, and another in what we call signals and systems. So these are fairly mathematically oriented conceptual classes and kind of follow on to the class that Professor Ortega mentions he teaches at the freshman level. Well, I also have taught the Freshman Academy course, which all of our freshmen will also take.
Awesome. Sorry to jump in at that. Well, again, for all of our guests, we have some fantastic faculty here from the Ming Hsieh Department of Electrical and Computer Engineering. I'm going to launch a poll that I should have launched in the beginning, but I forgot. So I'm launching this poll for all of you that are in attendance, so you can let us know a little bit more about yourself. And as a reminder, please hold your questions from now. You see the Q&A feature down there? Don't touch it. We'll get to the Q&A feature toward the end. You'll have plenty of time to ask questions, and we'll get to as many as possible. For the time being, please fill out this poll so we can know a little bit more about you. And also, you get to dictate one fun question to our faculty. And so we'll see where that's going to lead us in just a couple minutes here. Let's get started with my first question for our faculty that I think our audience will be helpful for. It is a relatively simple question, but I'm sure complex in its answer. What is electrical and computer engineering?
Who wants to go first?
You want to go ahead, Mark?
Well, I was just going to say, I think when I get asked that question, I try to respond in that it's extremely broad, so it's hard to give, and that's why we're hemming and hawing a little bit. But I think it's trying to harness the natural phenomena of electrical properties of systems and to make sense of information, to use those to make sense of information and to extract, interesting features or to alter the information to turn it into something that is more useful. So I kind of like to think of it as information engineering in some ways, and then doing that with the electrical properties. I don't know, maybe Antonio or
I'll elaborate. We have a colleague, Professor Gupta, our former chair, and he likes to call electrical and computer engineering the liberal arts of the engineering discipline, meaning kind of elaborating on what Mark said, that it's a very broad field. our department is kind of organized in some of the focus areas that are available for your undergraduate degree, roughly into what we call systems, which is more, say, mathematical and conceptual in terms of processing information and signals and so forth, and computers, which is what Mark said, and this is a very important component of all of electrical and computer engineering. And then the third area is more in electrophysics, which has to do with physical properties of materials and making sensors and actuators. So that gives you an idea of kind of how we organize ourselves. And as Mark said, that's those three components. You can kind of see them as harnessing the physical properties of the world to manipulate information in a useful way for people.
Yeah, and another angle that you can see, you can answer this question is by looking at, an iPhone, for example, and seeing how many parts of that are related to what electrical engineers do. We're talking about the physical side of things, the image sensors, the antennas. You were talking about the hardware, the chips that are embedded, the processing, the architecture to build the whole thing, and we're talking about processing. So things like image compression, video compression, the communication channel codes. So really, in a system of that nature, you have all the areas of the department represented. Everything that we do, you can find there, and it gives you an idea of the breadth of stuff that is electrical engineering.
This is a tangential question, but I think appropriate for today. I was just tracking the shipment on my new iPhone due to arrive tomorrow. What should I be most excited about with this new iPhone?
Well, you're asking the wrong person. I have a really old iPhone, so somebody who's more up to date. I just have to be dragged kicking and screaming to buy something.
We don't have an answer. That's fine too.
No, I think it's 5G, but I mean, 5G is an incredible capability, but you need the infrastructure, so they need to roll out the services. But when the services are available, that's the biggest jump in technology that's available in the new iPhone.
It's that ultimate wideband that's
you'll be able to get much higher data rates, and one of the key components of 5G eventually is very low latency communications to allow, for example, to control autonomous systems in factory floors and unmanned vehicles, coordinate their traffic patterns on highways and things like that. That's what 6G is really going to do a good job at.
6G. We're already on 6G.
5G is the first cut at doing that kind of stuff.
Mm-hmm.
Awesome. Sorry, I was just tracking my shipment. I got really distracted there for a second. I shouldn't be doing two things at the same time on the screen. So let's talk a little bit about the undergraduate curriculum in electrical and computer engineering. Now, granted, there are 3 different specializations, and so it can splinter in a lot of different ways. And there's also the jointly administered program of computer engineering, computer science. So this is a really big question, but how can someone understand our undergraduate curriculum as they're coming out of high school, in their first year?
So I think, there's first year, maybe that I'll start there and then I'll pass it on to Mark.
Great.
But, I teach primarily students in their first semester. And so one really cool thing about our program in the first semester is that most students are doing 3 classes in electrical engineering in the first semester. And that means that as a group, they get to know each other. They're going through the same kind of experience and same classes. And those classes are the one I teach, linear algebra, which is math and ties to the systems topics, signal processing, communications, controls. Another one is 155, which Professor Gupta teaches, and that's an introduction to programming, but mostly about problem solving using programming, right? Because we want our students to think that programming is a great tool. It's not an obstacle to anything. It's just a great way of solving problems and building things. And the third class is 105, which is an introduction to all of electrical engineering. And it's a sampling of, various, areas and things that could be specialties. And, they start together. And one thing I see is that because they start together, they continue going through many classes together. And that makes it a very, very nice cohort, very nice group. We're a small department, at the undergrad level. And they all start together first semester. So maybe Mark can say a little bit more about where things go from there.
Yeah, so I mean, I think that is a great point, Antonio, is maybe unlike some other places, we kind of let you get into electrical engineering in the very first semester. And then, as I think Professor Chugga said, the curriculum is broken down into those 3 areas of systems, computer engineering, and electrical sciences. And so the 3 classes you take in your first semester roughly kind of correspond to those three areas. And then you build on that. So the way the undergraduate curriculum is laid out is we have a core set of curriculum that has essentially 2 classes that you take from each of those 3 areas. So you can get a sense of what is this about and get essentially the fundamentals you need to go into any area. And then you usually kind of knock those out in your first 2 years. And then by your 3rd year, you're able to kind of choose, because you've taken these classes, where you'd want to focus in. And then you could get into technical electives and get some depth in at least one of those areas of your choice, while still being able to, pick other classes that are of interest to you. But then, yeah, so within the first, year and a half, you're taking 5 or 6 electrical engineering classes to really give you a good sense of what it's about. I don't know, Keith, if you want to add anything, but
I just would amplify what you two said. So first of all, one of the things that Professor Ortega said is that we are a relatively small department. So to give you an idea, our incoming class in ECE every year in the undergraduate program is around 50, 60 students, roughly, somewhere in that order. And we have, probably 65 faculty in our department. So we have a lot of graduate students, but this is a very small undergraduate program. And, I went to a very small undergraduate engineering program, but it had no graduate program and it had, 600 students. So USC is very unique in that we have 40,000 students on campus and we have a medical school. So it's a full-blown large university, research university experience, but within ECE, you're going to have a very tight cohort. You're going to get to know everybody in your class. And then, I think what Mark said on the classes is correct, that, and one point you should take from that is, even if you think you want to do computer engineering and you should keep an open mind, because you might in the first year or 2 find out you really love electrophysics, and you didn't know it yet because you didn't know what it was. And I guess the other thing that we should talk about with the curriculum is the CECS program. I don't know if you want to cover that separately, Paul, or?
Yeah, go for it. This is where I was going, actually, so this is perfect.
Okay, so I'll mention it, and then Mark is the most knowledgeable about this, so he could follow up. So we have a computer engineering, computer science program. It's a joint program between our department and the computer science department. So roughly speaking, you could think if you study computer science, you're going to learn software. If you study computer engineering, you're going to learn hardware. If you do CECS, you're going to learn both. And more recently, we've kind of provided 2 emphasis areas, 2 tracks within the program. And one is a little bit more focused towards computer science, and one is more focused towards computer engineering, and the one or ECE. And in the ECE focus, it is essentially a curriculum focused on embedded systems and IoT. And so we have embedded systems class that Mark typically will be one of the instructors, and we have an IoT class. These are 2nd semester, 3rd semester courses. So Mark, you probably have more to say on that.
yeah, sure. I mean, as Antonio kind of mentioned, a lot of the electronic devices that you're going to be using are embedded inside to control or to be used in another device. So whether that's your phone, or it's in a robot, or it's helping fly the plane or drive the car that you're in, these are devices embedded in others. And so we try to use that as a vehicle to teach many of the electrical and computer engineering principles. So yeah, that's a new kind of track that we've created. And that really is interdisciplinary between computer science, software, and ECE hardware, and sensors and actuation and all these kinds of things. So we've built a program kind of that's built around that. It's been, I think, well received. It gives you, I know a lot of students, want to have that fundamental ECE background and do some computer science as well. And so this gives an option for people that are inclined to that to have both.
So
can I say one other? Can I? Sorry,
Wait,
can I mention one other thing, Phil? Paul, is that I think one thing about our curriculum is we really want to have strong lab experiences, and so a good number of the early ECE classes have strong hands-on labs component, and I think that's been a really useful feature. And even now in kind of the COVID season, we ship our boxes with lab equipment to you. You're able to do a good chunk of your labs, both in your freshman and sophomore year. And hopefully that we'll never have to ship a box again. So that's my hope. But, I think we don't want to sacrifice on that hands-on experience. And so right in your freshman year and sophomore year, we want to give that to you.
Can you describe what some of these hands-on projects are as they go through that? And then ultimately, you mentioned this, but how did we shift these ideas to the COVID age?
Yeah, sure. So in your very first semester, you're in E105. It's kind of an overview of the entire class, and they'll have some basic labs to show you that. I can speak more to the classes that I teach, which is computer engineering class. So we actually use small microprocessor boards that can interface to the outside world. So like if you've heard of an Arduino or Raspberry Pi, we ship those to you, and you'll be building devices that you'll write software that interfaces to sense what's happening in the physical world and then control what's happening as well. And so by the end of the semester, we built, you can control your, we built like a Nest thermostat kind of device. We built, in the past, we built a projector controller. So you can, on a projector, you can change which source you're viewing, zoom in, zoom out, all with some like a twist knob or some buttons on your own device. And then in sophomore year, there's an IoT class, and you can now start to wire these things together to work remotely and develop kind of systems of systems, not just one entity.
Right.
Yeah. Go ahead.
Sorry, even the class I teach, which is really a math class, and it's about concepts. We have MATLAB software labs every week.
Mm-hmm.
The good thing about that is you don't have to ship anything. We can still do it, remotely. So the labs go on, and we do things like some image processing, some audio processing, a little bit of machine learning, things like that. With the tools of linear algebra. So from the very first semester.
Mm-hmm.
Yeah, so just very similar to what Professor Ortega said for the junior level classes like signals and systems. There's each week there's computer assignments, computer labs, and depending on the size of the class, I have given more student-defined projects. And one of the things that to carry over to what Professor Redekop said was the students keep these Arduino boards or Raspberry Pi boards. They typically had an Arduino board, and so one of the popular projects would be something like making a wah-wah pedal for an electric guitar using the Arduino that they got from Mark's class in my class. So they're using, their hardware experience from Mark's class, but they're using new knowledge from the signals and systems to do something cool with, a musical instrument.
So the curriculum definitely keeps scaling up as they go, which is awesome.
Mm-hmm.
And as a reminder to our guests, most of you have been really great about this. Please hold your questions until we get to that point, and then we'll open up questions at this time. But so please hold those questions for now. So I like that we kind of talked about the curriculum, the undergraduate programs, the specializations, and then the joint program. And we have a number of our guests, I recognize a lot of names here, that were at the computer science session. So who wins? What's better? We got students that are thinking about computer science. We did a great description, Dr. Chug, of computer science being software, electrical and computer engineering being hardware, and then CECS is kind of that joint program in the middle. Students are coming from high school with probably background in programming, maybe this fascination with programming, and so they don't see or have that idea of ECE. What should students know about the differences and what's better? I know we have a biased audience here, but hey, we can control it, right?
Yeah. Well, maybe I'll just say this. So I am definitely biased. I actually did my degree work at USC and was a CCS major. And with that degree was able to, in my job, in the consulting work, have developed hardware and written operating systems for airplanes and all these other kinds of things, and been able to go back and forth multiple times. So I think of CCS as essentially giving you the knowledge of how hardware and software, where they meet, and how you can work on kind of either side. and any kind of software development that you would want to do that isn't just maybe like, your full stack web dev, but that actually requires some knowledge of the hardware to either make it more efficient or to actually accomplish your task, then that's where CECS kind of focuses. It kind of gets down to that level of detail. So, a lot of students come in, they're interested in robotics, and they're interested in other kind of applications like that. And that's where CECS is trying to kind of focus itself. And even within that, like we've said, there are different tracks. So if you find, hey, I do want to have I'm more CS oriented, but I want to have that understanding of the hardware. So my software code is, performs better. It's well written. It can take advantage of certain features. Then there's that software track. And then if you actually want to design the hardware, there's more the embedded systems hardware track.
That's great. And I'll also add, although this is not an admission session, we have admission info sessions later. We'll put links off in the chat so that students can sign up for those. You should know that you don't have to feel worried about this admission process. Not one of these programs is more competitive than another. We don't have any impacted programs. When you're looking at the admission process, just choose whatever sounds the coolest to you, because you're also not locked into any of these programs, and students regularly migrate or move between these. Students start in ECE and move to CS, students start in CS, move to ECE. That spectrum is very fluid. So don't worry too much about it. And it's also, as the faculty have described, this program and the understanding of engineering is it's an experiential process, and they've set up the curriculum as such. So you can start to experience these coursework and start to see what you like and what you're interested in as you start diving into specializations or areas of interest of yours as you go. You're not supposed to have it figured out before you start, and we're gonna help you with that. Let's talk a little bit more about research. Research in the department, research that maybe you might be involved in or others might be involved in. What's going on in the world of electrical and computer engineering?
So many things. So let me start with my own research.
Yes.
So where I started was, where I did my PhD. I was interested in image and video coding, and so I followed what's happening in that world for the last 20 plus years. And I think this is similar to other areas of engineering. The main thing that has happened is that computation has gotten cheaper, right, and memory. And so Moore's law means that we can do things now that we couldn't do 20 years ago. We can do things that are more complex. We can use more data, and we can capture more data. So a lot of what's happening right now in electrical engineering is how do we manage all this data that we're acquiring and transform data into information, right? So we're just both working with the physical world and trying to convert, electrical signals to information, but also in, the information world, how do we convert all the data that we can capture from sensors, from devices into information. So in my own research, I've worked with compression, how to squeeze, video conferencing into channels so that we can be doing Zoom all day long and still, manage to do all this remote learning. And more recently, I've been involved with analyzing data sets on graphs that are, things like sensor networks, social networks. And so I think I would describe my area as analyzing information, doing processing, extracting useful information from raw data. I would say that's what I'm doing. And in the field as a whole, I think we're very impacted by the fact that we can do so much processing. So that opens up lots of possibilities for new algorithms, for new devices. And it's great. It's a great moment to be working in this area.
Can I ask a follow-up question, Dr. Ortega? Is your artwork background related to what you just described? It looks like it's an algorithm-based painting here.
So let me tell you, this is a great story. So I just finished a book on my core area of research. This is the cover of the book.
Cool.
Now, the more interesting part of the story is that this was done by one of our undergraduate students, whom I think you all know. And she took my class. We had some research discussions, and she's an artist. She's a dancer. Cami,
Okay, this is Cami's painting?
Yeah.
Awesome.
So she after some discussions, she brought this, and I said, "Oh, this is pretty cool." And then I asked the publishers, if they would like this as a cover. I said, "Yeah, that's great." So this is the cover of my book. So it's related to my research done by one of our undergrads.
That's really cool. I'm glad I asked. That's awesome.
Yeah.
Awesome.
Other thoughts on research, or do we cover? Is there other things you want to talk about?
I could say a little bit about my research and maybe more broadly about our research in our department. So I really would echo what Antonio said, maybe because we're separated by only a year or two in our development. But my PhD thesis was, I was working in the area of communications, wireless communications, and what was new back in those days of introducing cellular was trying to move more digital data through wireless channels where all the platforms were moving. So they're on, buses, trains, airplanes, et cetera. And that creates a lot of challenges for the receiver processing. And so my research at that time was, what conceptually would be probably totally impractical as an algorithm, but what would the best thing you could do be? And so we looked at that from a theoretical perspective, and then said, oh, here are some approaches that you could look at. And then within 5 years, it was all happening in real receiver modems. And so that's exactly what Professor Ortega mentioned about. We've been leveraging Moore's law for many years, especially algorithm or processing people like Antonio and me. And now what's happening in several ways, there are several components to that. So what's happening is Moore's law is running out. So this idea that we're just doubling the number of transistors that can fit on a chip every year and a half is really hitting its physical limit. So people in computer engineering and in the electrophysics side of our department are really asking themselves the question of what's next in terms of computing platforms. So that could be quantum computing. It could be completely different technologies other than CMOS technologies, instead of planar architectures, multidimensional architectures, et cetera. At the same time, people that are a little bit more applied are working on, as a near-term fix, are thinking instead of running these things on computer chips, we need to learn how to build very quickly custom chips that do the processing job we need. And as Professor Ortega has mentioned, a big part of what's happening there is we have a lot of data, and we're starting to use machine learning, data-driven design methodologies. And so my current research is focused on how do you build application-specific circuit technology to do deep learning. And that's to save energy, speed the computational problem of training these large neural networks on large data sets, and also enable the ability to do this on edge devices, like on your cell phone or on a smart camera, or in military applications where you could have sensors all over drones or on humans. So a lot of the work going on in our department is really being driven by data science, and in particular, picking up the theme that Mark was talking about, CS versus ECE. We are connected to the physical world. So our data is typically not, just some archived data set that was pulled off, years ago. It oftentimes involves real-time sensors and the design of a system that's going to collect data, interpret data, and take actions in real time. So we're also building up autonomous system research groups in our department, robotics groups, computer vision groups, things that integrate all those things together. So that's kind of a higher level overview of what's going on in all of our department, I think, from a research perspective.
And you mentioned machine learning, and this is not far from any of what we're all doing. And I think you mentioned the side of building hardware that is well suited for this, but also there's so much data, and it's so easy to train some of these systems that I think there are theoretical questions about what it means, right? You can get enough data to train a system to give you an answer to some question, but is that really a solid answer? Will it stay reliable if you change the input slightly? And these are all fundamental questions that are very important, because otherwise we lose control of the systems that are used to determine, I don't know, credit scores and in banking or health decisions. And unless we know what's happening in those black boxes and we know how to train them in a way that is reliable, we're not developing and deploying safe technology. So that's also a very important question for many of us in the department.
That's great. Thank you. That's a really great overview. I got two more questions for you before we open up to our audience. And one of them is on outcomes. It's regularly widely known that students have lots of professional opportunities at the USC Viterbi School of Engineering. They get internships quite commonly over the summers, and they go on to get great jobs. So where are they getting these internships and jobs? What companies are they working at, and what are they doing, if we know?
You want to go with that, Mark?
Sure. I mean, again, it depends on the field or the specialty, because again, with the breadth. But I can just share just two stories. So in the last 2 years, I've had two former students, one from Microsoft, one from Apple, who are actually working in. I've had some students in their software, but these are actually in their hardware groups within Microsoft and Apple. Come and say, we want more USC students. There's something about what you're doing with your embedded systems kind of training that we're really, these students are doing great in their work. Can you give us more recommendations? And so you can work from some of these like large companies, the Googles, Microsofts, Apples of the world. But then there's many small startup companies, and aerospace also is an industry that hires quite regularly from ECE, I know. So it really kind of depends, like I say, on what your interest level is. But yeah, there is many opportunities, both for internships and for full-time jobs after your graduation. So I don't know if others want to share.
Yeah, I think for the large companies, the ones that you can think about that you mentioned, Google, Microsoft, Qualcomm, some of the aerospace companies, Northrop Grumman, Apple, we will have students in all of these, and then there are students who follow some different paths after graduation, and may go into consulting or go and get an MBA, or who knows, right? I think it's going back to the theme of liberal arts. I think you're getting background in math, programming, hardware, physics, right? So there's lots of things you can do afterwards. But certainly these large companies, they all hire our students at all levels.
Yeah, I think it's hard to find a company, a technology, or a service that doesn't involve some sort of electrical and computer engineering at its core. Circuitry or a power source of some sort. And so all the companies you mentioned, of course, and one of my favorites, because you brought up CAMI, is theme parks. Whether that's Disneyland or Universal Resorts. I was just talking to Cami, I think it was 2 weeks ago, and we were talking about her internship at Universal in Orlando. And it turns out that she's involved in ride design there as an intern. And the Hogwarts, I'm not a Harry Potter person. What's the motorcycle ride? Does anyone know what this is? I'm going to get killed with this audience. But basically, whatever Hagrid's magical motor, whatever that is, she helped design some of that. She actually has a part of that ride named after her.
Oh, cool.
It's called the Cami because she helped develop it. I'm like, that's the coolest thing in the world. She goes, it's a small part, it's not important. It doesn't matter. That's the coolest thing. As an intern, you did that. So that's really cool.
Cool.
Last question. Engineering is also in Glendale. And, I've had undergraduate students in my class that were joint cinema and ECE majors, and they've gone on to careers at Disney. And
absolutely.
Can I say one thing about that too, is just that the ECE, the way the curriculum is set up, we have a lot of students who have minors in other like totally disparate entities that they're interested in. So I've had theater, music, all kind of business, law, all these things. So that's one nice feature about the curriculums that allows you to follow some other pursuits if you are interested.
Yeah, audio recording being very fun. There actually is a new minor that is related to theme parks, and I can't remember what it's called off the top of my head, which I learned about recently. It's just these minors grow all the time. Yeah. Last question for our faculty before I open up to the Q&A. And in the poll, you all told me what to ask. So we said if we have time for a fun question, and that poll is, everybody voted on this. It says, if you weren't a professor, what would your younger self be hoping you were doing professionally right now? think back to those years, just maybe 10 years ago. You're young, your younger self back in the day. What do you think you're going to be?
I mean, when I was young, I didn't really, I'm the first generation in my family to go to college, and I didn't know much about professional opportunities. And when I thought back, I was like, well, how did I become an engineer? But now that I'm in my 50s, I look back and I knew I would always be an engineer. It's obvious that I would always be an engineer. So I would say, if I look back, my biggest dilemma has always been to be a professor or to be a practicing engineer in industry. And one of the great things about being in academia is you have some flexibility. So I've been able to pursue some entrepreneurial activities, get a lot of exposure to practical engineering, at the same time do the things that I love to do at USC, which is mentor students at the undergraduate and graduate level and explore exciting new ideas and be surrounded by interesting colleagues who are always coming up with crazy ideas and new ideas and exciting, challenging us intellectually.
I mean,
Right.
Go ahead, Antonio, please. No,
Yeah,
please.
so the first thing I want to say is that I certainly didn't grow up thinking that I would be a professor, and I think I went into doing a PhD without knowing that I wanted to be a professor, and then it's just the whole thing happened when I started looking for a job, and here I am. If I wanted to do something completely different, I really like literature, and but I think I was clear-headed enough to realize that that's a very difficult thing to do, to write and to make a living out of those kinds of interests. And when I was in high school, I enjoyed math and programming, and I feel that electrical engineering is a great place to build things, to be creative, to develop ideas in those that involve those kinds of tools. And so not a bad choice.
Mark, I'm gonna hope you're gonna say basketball player.
Yes. So, man, if I just could grow 6 inches and actually jump, I would definitely be a basketball player. So I love basketball. I play sometimes in the student gym, and for a while I actually could kind of blend in, but the other year somebody said, "Hey, you look like my friend's dad," and then I realized that's the time I need to so that was fun.
All right, let's get to our Q&A. Let's let our audience jump into that Q&A. We're going to get to as many as we possibly can. Guarantee we're not going to hit them all, but I'm going to get to as many as we possibly can in that Q&A feature. Also, as a note, we're not going to be going into any admission or application questions because we have our faculty here. Let's learn from them about the discipline, about the department, about the classes, about the coursework, etc. If you do have questions related to admission, I do encourage you to sign up for one of our admission information sessions. We run them 3 times a week. We have one specifically for first-year students and one for transfer students as well. So you can go to that link I just put into the chat for everybody to sign up for one of those sessions, and I hope we're going to see you there soon. So let's see what we get involved in this. Here's a great question. I'm going to start off right now. It's a research-specific question. It's about robotics and autonomous systems. Can we describe what that is? And what I think the question is actually asking, what is it, and how does that get involved into the school, these research centers, specifically robotics?
Yeah, robotics is probably the most cross-disciplinary area in the School of Engineering, because it involves typically computer science, mechanical engineering, electrical engineering, and sometimes biomedical engineering, depending on the application. So it involves all of those things. In the context of electrical engineering, it involves building, it's closely aligned with the classical area of control systems. So that is, how are you gonna make the robot, say, balance, walk? How are you gonna integrate sensor information like gyros, accelerometers, cameras, acoustic sensors, to integrate all that information and then process it and then turn that into what we call actuation, which is movement or just taking some actions. And so it really is kind of a very integrative topic these days.
Great. We have some questions here. that are all revolving around research, and one of the themes of these questions is, can undergraduates get involved in research? The answer is yes, but can we talk a little bit more about how undergraduates are involved?
Yeah, so they're involved in different ways. We have formal programs. They can do directed research, and they even have the option of doing thesis. And I think for undergrads, there's a couple of challenges to get involved in research. One is that you need quite a bit of background to get started, right? But the other one is that research is very different from taking class, and so there are lots of setbacks that you can encounter. You don't always know where you're heading, and so it's difficult to plan. You have to be adventurous, right? You have to start with some ideas, nobody really knowing where the project is heading, and then be patient and have some curiosity and see what happens. But there are plenty of ways. As we've mentioned, our undergrad classes are small. So when I have students reach out to me about doing some research, we start talking, and there are plenty of chances to do it.
Yeah, I was going to say a lot of it, I think there is some formal process that you can go through. I think there's even a merit research program that will even potentially for certain students, if you qualify, pay you some small stipend to be involved and help with that matchmaking process. But I tell most students that it really is based on your initiative. A lot of the faculty are very willing to work with undergraduates, potentially even if you don't have that background, like Antonio is talking about, to come in, at least sit in on a meeting on occasion, or to see what's going on in the lab, or to work with other doctoral students and help them out. So, but it really is a lot of based on your initiative. So I just encourage students, look at what some of the faculty are doing. You can visit the websites, you can go talk to faculty and get a sense, and then pursue what you're interested in. Like Antonio says, you have to be curious, and you need to learn and do a lot of independent, work yourself. And then when faculty see that, then it becomes a nice on-ramp. You can talk about projects you've done or interests you have and how those might align. And they can even guide you to faculty who are working in that area. So a lot of it is just based on your own initiative and what you're interested in, what you're curious about.
That's great. Danny Davis, thanks for your question, Danny. There's a series of questions, and so they're all really good though. First off, he gives you props, saying it's very interesting and very exciting. And so brown nosing gets you everywhere. So that's a great job, Danny. What are the students like in electrical engineering? And short answer, there's not going to be an answer to that, but let's see what the faculty say. And what do they like most about electrical engineering outside of you three teaching their classes? And how do their outside interests combine with their engineering work? It's a lot there. So pick and choose what you like.
Mm-hmm.
Well, I'll start. Whenever I teach undergraduate courses, especially when I had a college age, my kid was getting ready to go to college, I was always curious to talk with the students about their college experience. And one thing I can honestly say is whenever I polled the students in the class, it's been a couple of years since I've taught an undergraduate class because I've been involved in developing a machine learning master's program and teaching those classes. But every time I'd ask them, how do you like USC? They all would rave in a genuine way about how much they loved USC. Their one complaint, which full disclosure, was the Wi-Fi. So I don't know if we fixed that, but that was their one.
How long ago was that?
It's about 2 or 3 years since I've taught a class on the undergrad program. And although I'm teaching them again in the fall, so I'll get an update. So they all really love it. And the other thing I find with our undergraduate students is, as we alluded to before, they all know each other. So it's a fully connected social graph. Everyone knows each other. They all are very close, and they're all very involved, extremely involved in a lot of things. And in particular, they are involved in a lot of these engineering club activities, like the underwater autonomous vehicle competition. And we have a race car competition, and we have a rocket competition, and we have a microsatellite competition. We have a number of these things. They're not for credit. They're just for, experience and for fun. And the students love these, and they're all involved in some of these aspects. So that's my experience with the undergrads. From the faculty's perspective, sometimes we think like, you don't have to do everything, just cut it down a little bit, because sometimes I feel like, and maybe it's a generational thing, the students feel like, I'll do all the things, and then at some point, it's like they're just completely overloaded and they can't focus on what we're trying to teach them in our classes.
I'll add to that. High school students, we have a number of high school students, we also have some transfer students in the audience, but mostly from a high school student perspective, it's that invincibility. I'm going to do 4 majors. Sure, and yeah, let's see how you do after your first semester. And everybody kind of, I think, adjusts their scope a little bit once they start taking courses and they realize this is enough work on its own. But that's also why the major minor combinations work quite well. I'm sorry for jumping in there, but I resonate strongly.
Yeah, no, I completely agree with what Keith said. But one other thing I wanted to mention is that they're also very willing to help each other. And one of the great things about teaching undergrads is I use undergraduate students as teaching assistants, course producers in the classes. So, I have students who took my class last fall who are now helping students taking the class this fall. And, every semester I get multiple volunteers from the previous year's cohort. And, it's great that they give suggestions, they have office hours, they help students. So they really get involved with, with this as one more activity, right? I also ask them to focus a little bit more, not instead of 10 clubs, make it just 1 or 2. But yeah, they're very active. They're involved with clubs, competitions, even as teaching assistants in research. I don't know where they find the time, but they do all of this.
This one I think is going to be the one we're probably going to wrap up on, and this is probably an opportunity to touch whatever else you want to touch on. How should students compare electrical and computer engineering at USC to other top-notch institutions that they may be thinking about applying to, and I hope that they're applying to? Anything unique or different about us? We've actually, the whole hour is actually the answer to this question, what we've been talking about, but what are some things you want to highlight for our students as they go through this program?
Well, I touched on it before, but I think what's really unique about USC is it's and ECE in particular, is it's a full-scale, large research, top-tier research university, which is scaled. So it's not a 5,000 student university. It's a 40,000 student university, medical school, business school, theater, cinema, everything you can imagine. So you're going to get a really broad exposure to lots of different kinds of people at USC. And at the same time, we have an ECE undergraduate program, which is quite small and it's quite intimate, for lack of a better word. Everybody knows everybody. And like Antonio was saying, helps everybody out. The other thing that is unique, so for example, not to point out any schools, but if you were to go to UCLA, for example, it has a similar profile as an overall university and as a graduate program in ECE, but their undergraduate program is going to be much, much larger than our undergraduate program in ECE. The other thing about USC, which is world renowned, is that we call it the Trojan family. So once you come into USC, you kind of, it's like Hotel California, you can check out, but you can never leave. So that means we have a very tight alumni network. And when it comes time to look for jobs and to seek out advice, there's a very tight community in all across the US, all across the world, of USC alums that you can reach out on and draw upon.
I would also maybe just quickly echo that the exposure you'll get in your first semester and first year, I think, is sometimes different than other universities that will kind of you'll hit the ground running with your ECE courses. And yeah, so rather than having to go through several years of math and physics before you can really dive into that.
Anything else you want to touch on before we wrap this thing up? Closing thoughts? Well, with that, I do want to thank you all for attending this program, and also thank our faculty for creating this discussion. Dr. Ortega, Professor Redekop, Dr. Chug, I really appreciate you taking the time to do this and meeting with our prospective students. If you have more questions, if you want to talk a little bit further, I encourage you to attend one of our admission information sessions. I put a link into the chat. You can also email us at vadmit@usc.edu. You can call us at 213-600-9919. That rings on our cell phones as we're all working from home right now in the admission office. The application's available right now, and you can make sure that you can get that submitted no later than December 1st. December 1st is the deadline if you want to be considered for merit-based scholarships, and all of you do. If you're a transfer student, your application deadline is February 1st. So you got nothing to worry about right now. Just sit tight, keep working hard your coursework. Other than that, I hope you all are keeping safe. I hope you all are keeping well. We look forward to a day where we don't have to do Zoom sessions like this and we can talk to you in person. Thank you so much for being here, and have a great evening. Thank you, faculty. Have a great night.
Thank you.
Thanks, Paul, for that faculty roundtable. Great to learn about electrical and computer engineering. As a mechanical engineer, I obviously love hardware. I believe in hardware as the most fun. So I have a lot of respect for electrical.
Well, you were involved in doing like hardware device production at Microsoft, right?
Yeah. So the past 2 summers, I have worked on displays, like computer displays at Microsoft for their Surface products. So I think that's, definitely an example where it's a electromechanical problem. So a lot of mechanical and electrical engineers working together.
Yeah. And I just love the mention of Cami inside this episode. Cami is our resident artist. She's behind a lot of the artwork that goes up on VSA produced stuff, like the Instagram comic, Viterbi Life, is a lot of Cami's production. That's her stuff. Her artwork on Dr. Ortega's book is going to be amazing. Hopefully you all can see it soon. If you watch the YouTube video, you can see Dr. Ortega's background, but it's a really cool watercolor painting. And again, just emphasizes that you as a generation that are out there coming into engineering, you're not supposed to just be an engineer, and you have different passions, you have different interests. This is a place where we want you to continue to do those things, and we hope you're going to continue to do that. And although this conversation was about how it related to engineering, it doesn't have to relate to engineering. It's just about stuff that you like to do. Everybody is different. Everybody has their own individual interests, their own ideas of how they like to spend their time and what makes them a complete person. Don't discount it. It's going to be part of your life as you move forward. So thanks so much for joining us for this episode. I think it's gone on long enough. I really appreciate it. And we will see you next time. We got one more bonus episode. We're going to sneak out to you sometime soon with one last academic department.